Hey, what's up guys? Welcome back to another video in the Deep Learning with Tensorflow series. This should be a short video, but I'm going to be showing you guys some more things that you can do with a sequential Keras model and also the flatten layer. So in the last part, I showed you guys how to do handwritten digit classification. So I just made a copy of that notebook that we used for that episode. First things first, I want to introduce you guys to a new layer. So far, we are familiar with the input layer, so Keras.input, and then the dense layer, which is just a normal standard dense layer for our neural network. But we also have the flatten layer, which will automatically take a input and flatten it. So what I mean by that is currently we're feeding in images, grayscale images into our neural network. But before we do that, we have to pre-process it to reshape our 28 by 28 matrices into a vector. This is because for this simple type of neural network here, it only expects a vector as the input for each sample. It cannot do anything multi-dimensional. And when we flattened it, we used the numpy reshape function, really easy to understand. You just do -1, and then we're multiplying together the dimensions to get the new size of the vector that we're going to reshape it to. What's cool though is that you can actually add a layer to your neural network sequential model directly that will do this all automatically for you. You don't have to worry about specifying the dimensions or the size of the vector or anything like that. Okay, so let's go ahead and comment this out by doing Control/, and then we'll add after our input a new layer, tf.keras.layers.flatten. And we don't have to pass anything to this if we don't want to. And then now for our input, we're not going to be expecting a vector that's already flattened. We're going to expect the actual, for each sample, the actual matrix that represents the image itself. So a 28 by 28 matrix or tensor. So all we got to do is change it from 784 to 28 and 28 like that. And now automatically when you feed images into your model, it expects them as 28 by 28 images, which makes sense, but it will automatically flatten them to a vector for you. So just makes it easier for you. So let's go ahead and run this again. And boom, so now we have a new summary. We're printing out the summary of the model after we're done building it and compiling it. So this just tells us all layers besides the input layer. So we have our flatten layer that we just added. So the output shape of that is going to be 784, which is not something that we specified ourselves. It's automatically calculating that based on the input that we're feeding into the model. Because we specified our input as 28 by 28, the flatten layer automatically knows that it needs to output a 784 size vector for each sample, because 28 times 28 is 784. So that's really cool. And then we still have our dense 1 and dense 2 layers for the rest of the neural network. That part doesn't really change at all. Another thing that you can do when creating these sequential models here is specify names for both the model and the layers. And this is helpful for debugging purposes in the future when your models get more complex. So if we start with the model, you can actually specify after the closing list there, you can do a name parameter. So name is equal to, and then we can call it whatever we want. We'll call it MNIST classifier, for example. And then now when we rerun this part, when it prints out the summary, the model automatically just has the name sequential. But now that we specified the name manually, it says MNIST classifier. So that's helpful if you have multiple models, of course, so that you can, refer to them by name. And then also, like I said, you can give names to the individual layers. So we can do, for example, name is equal to, we'll say flatten. Currently it's called flatten 1. So if you rerun this now, it says flatten. There we go. We'll add names for these as well. So we'll do name is equal to hidden 1, because it's the first hidden layer. Name is equal to hidden 2, it's the second hidden layer. And then for the last one, we'll do output, because it's the output layer. There we go. So now the layers have their own custom names. So flatten, hidden 1, hidden 2, and output. One other thing is that you can actually build your model in different ways. So right now we're just instantiating a new keras.models.sequential, and then we're passing in this list here of all the different layers that we want to have in our model. Let me just comment that out. And we can do the same thing if we just take this. So model is equal to tf.keras.models.sequential, pass in the name. So the name will still be MNIST classifier. And then now from here, we can just add the layers that we want to the network, just one by one. So we can do model.add, pretty much just like a list. So you can do add, and then we could have our first layer. So boom. And then if we run this, it's only our flatten layer because that's the only thing we added, of course. So here's all of our layers added. So if we run this now, you can see it pretty much looks the exact same as before, just declared in a different way. So instead of passing it all together as a list, we're adding them one by one using the add function. It's really up to you which method you want to do. I kind of find this one easier to look at, or nicer to look at, just because it's just really clean looking. But sometimes for debugging purposes, you may want to add it one by one. And also you can, if you want to, you could print out the summary in between adding different layers. So you can see how the model is building over time pretty much. For example, this one has 100,000 parameters. This one has 109,000 parameters. So since it's now kind of functioning as a list in terms of like you can add layers and stuff like that, you can also pop layers. So for example, you could do model.pop. And if you don't know, pop is whenever you do that on a data structure, it'll just remove the last item from the list. So now when we look at the summary, we can see that the output layer is not present because we are popping it before we print the summary. Anyways, with that said, that's pretty much all I wanted to show you. I know this was a very short video, but I just wanted to show you guys how you can do different things with these Keras sequential models here. In the next episode, we're going to be learning about the Keras functional API, which allows you to create these models in a little bit of a more complex way. So now you guys should also be familiar with the flatten layer as well, so that you can take your input from the previous layer, which in this case was our input layer, and flatten it to a single vector with all the elements sort of combined together, and then feed it into the next dense layer. That's it. Thanks for watching, everybody. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.